Right, so the next bit of differentiation is differentiating around about trig functions. Okay, so we've already done a few, obviously, in higher, but we need to introduce, first of all, these different types of functions. Right, the main thing to not get confused about is the difference between these and inverse trig functions. So although this is an idea of kind of inversion, so 1 over cos x is in a way the inverse of cos x, when we speak about the inverse of cos x, we mean something completely different, which is why we basically have these three functions as well. So when we're talking about 1 over cos x, we call that sec x. When we talk about 1 over sine x, we call that cosec x, and when we talk about 1 over tan x, we call that cot x. Okay, so I'm going to introduce later the idea of differentiating inverse sine x. Don't get confused between that and these. Okay, these will very specifically be laid out like this. And if they're in terms of sec x and cosec x and cot x, what they mean is 1 over cos x. They don't mean the inverse of cos x. Okay, so don't get the two of them confused. Okay. Main thing to remember is which one each one of them is. Okay, so you'll see these a lot, and these will be in your formula sheet. Certainly, the derivatives of them will be in your formula sheet, and that's what we're about to come to. But you need to know that sec x is 1 over cos x, and so on and so forth. Best way to remember it: look at the third letter. So sec x has c as its third letter. That's cos x. Cosec x has s as its third letter, that's sine x, and cot x has t as its third letter, so that's tan x. Okay, so relate to one another. Okay, right, we obviously have graphs of these in the same way that we have a graph of a cos x, we have the graph of sec x. Okay, so it helps to know what the graph of cos x looks like to be able to do this, and if you think about it, you can probably draw these yourself. Okay, cos x, the graph of cos x starts at 1 and goes down to 0 at 90, and then down to -1, up to 0, back up to 1. Okay, so we can kind of use that knowledge to help us draw the graph of sec x. So we're starting here because we're doing 1 divided by cos x. And if we're doing cos of 0, that's obviously 1. 1 divided by 1 is 1. So it starts here. From there onwards, on the normal graph of cos x, it gets smaller, in which case the value of cos x gets smaller, in which case we're doing 1 divided by a gradually smaller number. So that value itself will become bigger, and so on and so forth, in which case the graph will look something like that. Not so important to know these. I'm not seeing many questions on these, if any questions on these. It's just one of those things that we look at. Do the same kind of idea with cosec x, and obviously the same idea with cot x. That's what they look like. As I say, you can work them out, so you don't necessarily need to memorize them. But the bottom line is I've rarely seen them being used. Okay, what we really want to look at is the derivative of them. So the four actually, because we do tan x now. You didn't do tan x in high, you might not have noticed that, but we looked at sine and cos, but not tan, so we're going to look at that one as well here. I'm just going to go through where we get the derivative of sec x from, how it comes about. But the point is all four are actually in your formula sheet, so you don't need to know these. It's just one of these things to kind of help you. Okay, so we're looking for the derivative of sec x. What we're going to basically do is we're going to write it in terms of what we know. We don't really know much about sec x just now, but we know that sec x is 1 over cos x, and we can deal with cos x, we can deal with 1. What we can think of that as is cos x to the power of -1. So you could actually do this with quotient rule, okay, but we're going to do this in terms of chain rule. We're going to think of cos x to the power of -1, not to be confused between cos to the power of -1x. And I know that's confusing, and I know when we write other things, it means the same thing. We just got to be very careful with trigonometry, okay? So this is not the same as inverse cos. So we're going to split it up into our two functions, in which case we're going to have y equals u to the power of -1, where u equals cos x, differentiate them both. We get minus u to the power of -2, in which case, this should be du by dx, and that should be dy by du. So du by dx, the derivative of this one would be minus sine x. Multiply them together to get our overall value, but just remember to substitute the u back out. Okay, we can simplify it first. Obviously, the minuses cancel out. That becomes over u squared, so it's sine x over u squared. And u we started with was cos x, so it becomes sine x over cos squared x. Right. Now you can take this and you can simplify it, and you can simplify it in a couple of different ways. So quite often we look and see if we've got sine x over cos x, which we do here. So we're going to split this up into sine x multiplied by sine x over cos x, multiplied by 1 over cos x. We know what this is from National 5, and we now know what this is. So it just becomes tan x multiplied by sec x. And that's our answer. That's the derivative of sec x. You don't need to memorize that because they're all in your formula sheet, looking something like this. Okay, so along with the other three, you've got the derivatives of each. So the derivative of tan x is sec squared x. The derivative of cot x is minus cos x squared x. Sec x we've just done, and cos x is minus cosec x cot x. Don't worry about memorizing them in any way. As I say, they are in your formula sheet, okay, which I'll give you when we get back. Okay. Right. So not to be confused between, not to be confused with differentiating inverse trig functions. Okay. So it helps to know what the inverse is. So the reflection of the graph of a function in the line y equals x is the graph of the inverse of that function. Okay, that's in a graphical sense, but basically what we're talking about is we're talking about one function takes us from a to b, the inverse function takes us back from b to a. That's what we mean by an inverse function. So we write it like this, f to the power of minus 1, okay, or inverse function. In which case, what we're saying, if we take a function, we find the function of an inverse of function, okay, it would just be x. Okay, if we're dealing with x's. This is a little bit confusing. Don't spend too much time thinking about this. Most of this is actually given for us, but it's just, again, one of these things. If you understand where it came from, then you'll hopefully memorize it a little bit better. Right, we're going to differentiate both sides because we're interested in the derivative of these. So the derivative of both sides, simplified. This is just the chain rule on the left-hand side. Okay, so we're differentiating outside the brackets, so it's f dash of the function in the brackets times by the derivative of the function in the brackets. Notice this is what we're trying to find. So we're going to rearrange this. The derivative of x is just 1. I'm going to rearrange this so that this becomes the subject and it equals 1 divided by that. Okay, right. The inverse of the derivative of the inverse of a function is just dy by dx. Okay, in which case we can rewrite that 1 over dy by dx is equal to dx by dy. Okay, in which case y is the inverse function of x. As I say, well, that is quite confusing. I wouldn't spend too much time kind of stressing about it, but go through it a couple of times if you want to, and it will hopefully make sense. Okay. So therefore, the derivative of an inverse function is equal to the derivative of the reciprocal of the original function. So we're just going to confuse you even more. Right, this is just a little example before we get onto differentiating the inverse trig functions, just to show you kind of two methods of doing this. So if we have a function f of x equal to x squared, we're going to find the derivative of the inverse. Okay, so if f of x equals x squared, then we can say that the inverse function is root x. As I say, if we've got a function that takes us from a to b, the inverse function will take us from b to a. So if we square something to get back to where we started, we square root it. Okay. Right, the derivative of the inverse of the function we've just shown is dx by dy. We're going to use that version to help us in this first method. Okay, so we're going to differentiate x to the power of half. We're going to differentiate this one. Okay, that's what we're doing here. Okay, so the derivative of x to the power of half, okay, is going to be half x to the power of minus a half, and we rewritten is 1 over 2 root x. Okay, so that's that side as the first method. We can also do a second method, which is using this side, dx by dy. So we know that the derivative of the inverse function is basically 1 over dy by dx, which is 1 over the derivative of the inverse of the function. Okay. So we know that the derivative of the function that we started with, so f of x is x squared, so the derivative of that is 2x, so we can kind of substitute that out. And then we know the original function, the inverse of the function, was just root x, so we can just write that as 1 over 2 root x. Either way is fine. As I say, we don't do a massive amount of it, so don't worry too much. What we need to really look at is actually doing these, but these are given in your formula sheet. Okay. So we're looking for the derivative of the function y equals inverse sine of x. Again, don't get confused between that and what we were doing before. Okay? So if y equals the inverse sine of x, then x will equal sine of y. One takes us from a to b, the inverse takes us from b to a. Okay? So dx by dy, so that's what we know to be the derivative of an inverse, is basically the derivative with respect to y of that inverse. Okay, so of sine y. The derivative of sine y is just cos y. Okay, so then dy by dx is going to be equal to 1 over dx by dy, which is just 1 over cos y. Right, the point is here, the problem is here, we've got our function in terms of y now. Okay, we want our function in terms of x. If we're dealing with an inverse of a function, we want it in terms of x. So what we've basically got to do is we've got to kind of work this into our derivative. So we know that x equals sine y. So this is the only thing I can really change back. Okay, I'm trying to change my cos y back to an x. So I've got to find a relationship between cos y and sine y. So what I'm doing is I'm using my trig identities from National 5. So this is a connection that I know between sine and cos. So I know that sine squared y plus cos squared y equals 1, in which case if I rearrange that, cos y equals the square root of 1 minus sine squared y. Complicated? Yes, I know. So what we're basically going to do is we're going to substitute the cos y out for 1 minus sine squared y, all square rooted, so that we can now replace the sine y with x, but just bear in mind it's not sine y, it's sine squared y, in which case sine squared y is x squared, in which case we can simplify it to that. That is your derivative of inverse sine of x. Okay, you get the other two as well in the formula sheet, so don't worry too much about the definition here. As I say, focus more on the fact that it is in your formula sheet, and just remember to use your formula sheet when you see this come up. So you're going to get a bit of practice on this. To be honest, it gets more difficult and it's used more often when we're working in reverse. So we're doing integrals. Okay, and it becomes a little bit more complicated. But we'll get to that probably not for a while now. Okay.